In order to understand chemical kinetics, we must understand a key concept, and that is the rate law. Now, the rate law represents the rate at which the reaction occurs at varying concentrations. So as the concentration changes, how will the rate be affected? And that is what the rate law tells us. The rate law does not provide information on the relative rates between various products and reactants, and it does not tell us how the reactants and products concentrations change over time. It only tells us how the rate is affected by varying concentrations, and we can see that in the equation. How is this R value altered based on these concentration values? What's also important to understand is that these values over here, the concentration of A, the concentration of B, these represent your concentration of your reactants, not your products. So when you write out your rate law, it's important to note that you do not include products. You're only looking at your reactants. When you're comparing relative rates, which is another concept, then you can use products and reactants. But when you talk about the rate law, you only look at your reactants. And once again, the rate law R tells you how changing the concentration changes the rate. How do these two correlate? That's what the rate law is telling you. Now, some key distinctions to note is that we know that these represent the concentration of the reactants, but these reactants are raised to powers, and these powers represent order of the reactions. So what is a reaction order? A reaction order represents the relationship between the concentration and the rate. And this will make more sense once we get into graphical analysis of various reaction orders. But for now, all we need to know is that the concentrations are raised to exponents, and those exponents represent the reaction order. Now here, the concentration of A is raised to the power of X, and B is raised to the power of Y. If I wanted to find the overall reaction order, the overall reaction order would be the sum of all the exponents. So in this case, it would be X plus Y. But if I just asked you, what is the reaction order of A? The reaction order of A would be X, and the reaction order of B would be Y. But the overall reaction order is the sum of all the exponents, and that's important to understand. Now, let's take a moment to talk about the exponents. So the exponents are most often positive integers. Sometimes they can be negative integers, and sometimes they can be fractions, but most commonly they will occur as positive integers. Now, another concept we must understand, which is often mistaken by many students, is that exponents do not correlate to coefficients. Now, what does that mean? Oftentimes, when we look at chemical reactions, it's written like this. A plus B will give us C, and then we have these molar ratios of each reactant and product. So if we have 3 moles of A, 2 moles of B, that will give us 1 mole of C. Now, oftentimes what students do is that they correlate these values to being the exponents in the rate law, but that is incorrect. These values do not correlate to the exponents of the rate law. These values do not represent the reaction order. Instead, we calculate these exponents through experimental analysis, which we will discuss later on. But for now, all we need to know is that if you're given only this balanced chemical equation and you're not provided any other detail, you cannot determine the X and the Y. Now, moving forward over here, so as I mentioned over here, the exponents represent reaction orders. Now, the most 3 common reaction orders that most students encounter is a zero order reaction, a first order reaction, and a second order reaction. So if my x value over here was equal to 0, I would say it's zero order. If my x was equal to 1, I would say it's first order. If my x is equal to 2, I would say it is second order. Now, this can also apply to y. If y is equal to 0, it'll be zero order. If y is equal to 1, it will be first order. If y is equal to 2, it will be second order. And all of these values provide us information into the relationship between concentration and rate. And this will all make sense once we go over the graphical analysis of what reaction orders look like. Now, if I took the sum of my exponents, I will get the overall reaction order. So if x was equal to 0 and y was equal to 1, my overall value would be 1, so my overall reaction would be a first order reaction. And to lastly finish off, we need to understand that K is our constant, and K can be calculated also through experimental analysis. If we're given these values, or if we can determine these values, we can figure out K. And K, the rate constant, is going to be affected by various constants and values, specifically the activation energy of a reaction and temperature. And we'll get into that more detail later, but for now I just want to mention this equation so we just have it in the back of our minds for later on when we discuss the rate constant K. Now, to conclude, rate constant, remember, it only includes your reactants, not your products. Your exponents do not correlate to those molar ratio values in a balanced chemical reaction. And your rate law represents how changing the concentration affects the rate.